Hey, Algebra 2. Here I am to talk about the extra unit. I don't know. I'm kind of trying to call it E. There's only going to be two lessons in this extra unit, E1 and E2. These are things that we are not going to have a test on individually, like just on this. It's kind of like a mini statistics unit. But there will be questions about this on your final exam. So I don't know. It's not enough to have a whole unit, but it's enough for a little to do here. So extra unit number 1, data distribution. All right. So data is a very important topic to me. It's a very every single one of you will be presented with data in your lifetime, whether it be on a newscast or the box office hits of your favorite franchise or whatever. You will be given data to look at, and data tells a story. And sometimes you can get data to tell a different story than what is actually happening based on how you display the numbers. So being able to interpret graphs and being able to interpret data is going to benefit you no matter what you do in your life. 100%. So we're going to take a look at kind of two different types of graphs today. And we're going to look at some different measures of center. So that's going to be your mean, median, and mode. These should sound familiar. So the mean is your average. So the add all data, divide by the number of terms there are in your data set. Median is the middle number. Mode is what appears the most. What term appears the most in your data. You will not have more than 2. You can have 2 modes in a data. That's called bimodal. 2 modes, bimodal. But you will not have more than 2. Oh, the sun just came out like, okay. So mean, median, mode, those are your measures of center. Then I've got a couple others, the measures of spread. So this is how spread out your data is. This is going to be like range. Range is your maximum minus your minimum. Tells you what's the difference between the lowest and the highest. Also, this is going to be where we find standard deviation. This is a number that says most of the data is within this amount from the mean, where most of the data is. Compared to the mean. All right, so let's jump into an example. So let's say I surveyed, I don't know how many this is, 16, I think 16 people, and I asked, how many shoes do you have? And I'm going to put these data, I'm going to put these in order. I wasn't going to, but it makes it easier, so I'm going to. I'm going to put these data in order. So 3, 2 people had 4 shoes, 6 pairs of shoes, that is. They don't just have 3 shoes. 15, 16, ooh. And 25. I'm going to just, hold on. There we go. and 25. Okay, so there's my 16 data sets. I've got 16 people who answered this survey. So with this, now I couldn't figure out how to get this little calculator to do it. If you do have a graphing calculator, you can type this into a list and calculate the stats for it. I also just found this, let's see, let me make sure I copy this. I found this statistics calculator. So I just searched in the Google measures of spread calculator, and this was the first one that came up. I already entered the data, so it's remembering it. You will just type in your data separated by a comma, submit. The data is from a population, not a sample. That's important. If this would be like if I'm trying to find out, often this is used for who the country is voting for. I'm going to estimate based on the whole country, based on the population, but I'm only going to ask 100 people. That's a sample. But in this case, I asked everybody. I asked the population, and this will just tell you all the stats. Absolutely, there are ways to calculate it by hand. That's not something I foresee needing truly in the future. So, got it. All right. So your population size, I asked 16 people. Your mean, so the average person that I asked has around 11.6 shoes. The average person. And the sometimes I use X with a bar above it. I think, oh, they used a mu. Couple different symbols for mean. You can have an X with a bar above it. You can also have this symbol like that. It's called mu. It's fine. Those are both symbols. They mean the same thing. It's just what's the mean. So on average, people have 11.6 shoes. This is a lowercase sigma. Sigma is the standard deviation. It is about 6.3 shoes. So this means that most of your data is going to be within 6.3 of 11.6. So let's see. This says most data between, I still see that, okay, 11.6 plus 6.3. Most people have between 17.9 and 11.6 minus 6.3 and 5.3. Oh my gosh. It's sunshine. Hold on. I'm going to try to block the light. There we go. Bizarre. Okay. So this says that most people have then between 17.9 and 5.3 shoes. And does that track, right? That's like here-ish to here-ish. Most data is there. That feels true. Most data is within 6.3 of the mean. Most data is in there. And yeah, only 5 people's shoe collections were left out of that statistic. All right, so then I've got the 5-number summary. This is the minimum, the first quartile, the median, the third quartile, and the maximum. And this statistics calculator does find these for you too. So the minimum lowest value, or you can just look at that, is 3. The first quartile, 6. The median, 12.5. Third quartile is 15.75. I'll explain what all these mean, by the way. And the highest value is 25. Okay. What does this mean? So did you notice the word quart quartile. Quart meaning four, breaking the data into four pieces. Okay, so let's look at where these are. So the minimum was 3, right? The first quartile was 6. The median was like here, right? Third quartile in these ones, third. And the maximum was 25. So if you notice this, each group is grouping 4 data points. So we've broken this data into 4 pieces, between the minimum and the first quartile, between the first and the median, between the median and the third, and between the third and the max. We've broken the numbers into 4 sections, 4 quarters, if you will. So this is going to tell us, we're going to make a box and whisker plot. This tells us, it like shows us visually how spread out the data is. So I'm going to make down here just a number line. And your number line, I'm going to start it at 0 and go up to 25. So let's count by 5s. Wow, this light is blinding. Okay. And it's just going to tell me where everything is on this graph. So my minimum is down here at 3. My maximum is 25. So all of my data is between 3 and 25. My first quartile is at 6 line. Median is at 12.5. Third quartile, 15.75. Here I have a box and whiskers. What this tells me is most of my data, like the where the data is, there's 4 data pieces here, 4 here, 4 here, 4 here. It tells me how spread out they are. This tells me that the most people have here in this quartile between 3 and 6 shoes. Most, or like a quarter of people have that. But the higher quartile is more spread out, things like this. This shows the spread. Where is the data? So this really, I don't know, I like the visuals of like half of the data is over here below 12.5 and half of the data is above it. So you could be able to say things like that. Where is the data? Okay. All right, we're going to do one more example. Your textbook just gave like a list of numbers, but I cannot handle that. I like to attach it to a thing. So I changed this to the number of cousins. I have 28 cousins personally, but my daughters only have 7. Number of cousins totally varies. 25, 27, 30, 32, 33. All right, so let's say I surveyed a bunch of people and this is what I got. Okay, that's fine now. A histogram of this data. In order to do a histogram, I need to kind of sort these data points into what are called bins in a frequency table. So the frequency and the bins. So bins is going to be ranges, and I want to keep these bins consistent. So let's say like between 1 and 5 could be 1 bin. So then the next one will be between 6 and 10, between 11 and 15, between 16 and 20, 21 and 25, bin between 26 and 30, and then 31 and 35. So I just split these into bins with with 4 numbers in it. That does include my lowest and my highest data set. Frequencies, how often did that happen? So how many data points up here fall between 1 and 5? Just 2. How many fall between 6 and 10? 1. How many fall between 11 and 15? 4. Between 16 and 20? Between 21 and 25? 26 and 30? Between 31 and 35. Whoa, 1, 2, 3, 4, 5. Okay. So we'll make a histogram here. Maybe just a little short one. 1, 2, 3, 4, 5. Over here, this is your frequency. How often did it happen? And then down here, these are like your bin lengths. So I'm going to go 5, 10, 15, 20, 25. Ah, man. Do it again. And 35. Okay. Sorry. Okay. Now I'm going to draw my, my bins. So here between 1 and 5, 2 people had that many cousins. Between 6 and 10, 1. A lot of people had between 10 and 15, all the way up to 4. One person. 2 people had between 25 and 30. And then 5 people had between 31 and 35. Okay, so looking at this histogram, this quickly shows us where the data is. There's 2 modes here. There's kind of 2 peaks. It shows us our data is pretty spread out. Like a lot of people have a lot of cousins, and some have an average amount. Keep in mind, where is the mean? The mean is right here. The median is kind of right next to it. So keeping in mind that that's kind of the middle of our data, same number on the left side and the right side. Things to keep in mind there. One thing that your book is really headed towards now is something called what type of distribution does it have? So see that this data graph, I mean, it's all over the place. There's not a clear pattern to it. But a lot of data has what's called a normal distribution. I'm going to just show you a normal distribution histogram. A lot more data points kind of look like this, where it takes this curve up and then down, up and then down. Things like heights, things like test scores, shoe size, enrollment numbers. Most numbers kind of go up and down by grade, something like that. So this is kind of where we're headed for our next